Welcome back to Fact Quirk Mindset YouTube channel. Before digging into the video, if you have not liked and subscribed to the video, please firstly, go and subscribe to the channel so that all the new updates will be notified on your phone. Let's go into the unique topic.
For centuries, humanity has gazed upwards. We looked at the night sky. We saw a fiery red point of light. This was Mars, our celestial neighbor. It captured our imaginations. We wondered, could there be life there? Could it be like Earth? Early astronomers with their simple telescopes saw what they thought were canals. They imagined vast irrigation systems. They pictured Martian civilizations. These were dreams, born of blurry images and hopeful hearts. But these dreams fueled a desire to know, a desire to explore. The red planet beckoned. The dawn of the space age brought new tools. We could send emissaries, robotic explorers. Our first attempts were fraught with peril. Many missions failed. The journey to Mars is long. It is difficult. The cosmos does not give up its secrets easily. But humanity is persistent. We learn from our mistakes. We try again. The early Mariner missions gave us our first close-up glimpses. They showed a cratered, barren world. Not the lush planet of fiction, but still, a world of immense geological interest, a world with a story to tell. These early missions paved the way. They revealed a world with giant volcanoes, deeper canyons, and evidence of ancient water flows. Water, the key ingredient for life as we know it. Suddenly Mars didn't seem so dead. Then came the rovers. These were our robotic geologists, our eyes and hands on another world. Pathfinder's Sojourner rover in 1997 was a pioneer, a small, plucky explorer. It showed we could drive on Mars. It captured the public's imagination, but it was just the beginning. The early 2000s saw the arrival of Spirit and Opportunity, twin rovers, designed to search for evidence of past water, and find it they did. Opportunity in particular was a marvel of endurance. It roamed Mars for over 14 years. It sent back stunning images. It provided undeniable proof that Mars was once a wetter place, a place where life might have thrived. Building on this legacy, a new kind of explorer was conceived, a mobile science laboratory, larger, more powerful, packed with advanced instruments. This was Curiosity. Its landing in Gale Crater in August 2012 was a triumph of engineering, a 7 minutes of terror descent. It captivated the world. Curiosity's mission was ambitious, to assess whether Mars ever had an environment capable of supporting microbial life. It wasn't just looking for water, it was looking for all the right conditions, chemical ingredients, energy sources, and of course, the lingering presence of water in the planet's past. Curiosity has been a workhorse. It has climbed Mount Sharp, a massive layered mountain in the center of Gale Crater. Each layer is like a page in Mars's history book. Following in Curiosity's tire tracks, but with an even more focused goal, came Perseverance. This rover landed in Jezero Crater in February 2021. Jezero Crater is special. Scientists believe it was once a river delta. Billions of years ago, a river flowed into a lake here. It deposited sediments. If life ever existed on Mars, this is a prime location to find its fossilized remains, or other biosignatures, telltale signs left behind by ancient microbes. Perseverance is not just a geologist, it is a paleobiologist. Its mission is explicitly to seek signs of ancient Martian life. Perseverance is equipped with a sophisticated suite of instruments. It can analyze rocks with unprecedented detail. It can identify their mineralogy and chemical makeup. It can even look for organic compounds on a microscopic scale. One of its key tasks is to collect promising rock and soil samples. These samples are being cached in special tubes. The plan is for future missions to retrieve these tubes and bring them back to Earth. For the first time, we would have pristine Martian samples in our laboratories. Scientists could study them with the full power of Earth-based equipment. This is a long-term effort. Section 4. Whispers from the Dust Organic Molecules and Methane Mysteries. The search for life on Mars is, well, a detective story. We look for clues, subtle hints. Among the most tantalizing are organic molecules. These are molecules containing carbon. They are the building blocks of life as we know it. Both Curiosity and Perseverance have found organic molecules on Mars, in ancient mudstones, in rocks that formed in watery environments. This is exciting, but we must be cautious. Organic molecules can also be formed by non-biological processes, geological processes, or they can be delivered to Mars by meteorites. So, their presence alone is not proof of life. However, the types of organic molecules found are interesting. Some are thiophenies, benzene, toluene, and small carbon chains. These are consistent with what we might expect from the breakdown of ancient organic matter. But again, non-biological pathways can't be ruled out. Scientists are working hard to understand the origin of these Martian organics. They look at the context. Where were they found? What other minerals are present? Are there patterns that suggest a biological origin? It's a complex puzzle. Each new discovery adds another piece. Each piece helps us refine our hypotheses. Then there is the mystery of methane. Section 5. The Next Wave ExoMars and the Global Martian Effort. The quest to understand Mars and to search for life there is a global endeavor. It's not just NASA. The European Space Agency, or ESA, has a major program called ExoMars. Its goals are very similar: to search for signs of past or present life. The ExoMars program includes the Trace Gas Orbiter, which is currently studying Mars's atmosphere. It is mapping methane and other trace gases with high precision. This data is crucial for understanding the methane mystery. It helps us see the bigger picture, how these gases are distributed, how they change over time. A key part of the ExoMars program is the Rosalind Franklin rover, named after the pioneering chemist whose work was crucial to understanding DNA. This rover is designed to drill deep beneath the Martian surface, up to 2 meters down. This is important. The Martian surface is bombarded by harsh radiation from the sun and from space. This radiation can destroy organic molecules. If life ever existed or still exists, its signatures are more likely to be preserved underground, protected from this radiation. The Rosalind Franklin rover will carry a sophisticated laboratory. It will analyze samples from deep underground, looking for complex organic molecules and other biosignatures. Section 6. The Martian Frontier Challenges and Dreams of New Worlds. Finding life or even definitive proof of past life on Mars would be a profound discovery. It would change our place in the cosmos. But Mars presents immense challenges. It is a harsh world. The atmosphere is thin, mostly carbon dioxide. There is no global magnetic field to protect the surface from solar and cosmic radiation. Temperatures are extreme, far below freezing for much of the time. Liquid water is not stable on the surface today. It would quickly boil away or freeze. These conditions are hostile to life as we know it. Yet, there are possibilities. Life could exist underground, shielded from radiation, warmed by geothermal heat, perhaps in pockets of salty water, which can remain liquid at lower temperatures. We know that life on Earth can thrive in extreme environments, in volcanic vents deep in the ocean, in highly acidic waters, in dry deserts. These extremophiles give us hope. They show that life is tenacious, it is adaptable. Section 7. Our Cosmic Destiny, the Unending Search for Kin. Why do we look to Mars? Why do we spend vast resources to send robots across millions of miles of empty space? It is more than just scientific curiosity, though that is a powerful driver. It is about understanding our place in the universe. It is about the age-old question, are we alone? Mars is our closest planetary neighbor that might have once harbored life. It is a natural laboratory, a place where we can test our ideas about how life begins, and how it evolves, or how it might die out. Finding even the simplest microbial life on Mars, whether extinct or extant, would be revolutionary. It would mean that life is not a unique fluke of Earth. It would suggest that life can arise on other worlds, throughout our galaxy and beyond. Imagine the implications. The universe teeming with life, perhaps even intelligent life. It would transform our understanding of biology, of chemistry, of our own origins. It would open up entirely new fields of study. Astrobiology would become a science with at least 2 data points, 2 examples of life. The search for life on Mars is a journey of discovery. It pushes the boundaries of science and technology. It inspires new generations of engineers, scientists, and dreamers. It reminds us of what humanity can achieve when we work together, when we aim for ambitious goals. The challenges are immense, but so is the potential reward. The knowledge that we are part of a larger cosmic story, a story that is still unfolding.